Hi everyone, my name is Praveen. Welcome to my channel. Today in this video I am going to explain the diameter form of the sphere and the example related to this. So without delay, let's get started. Let us see the diameter form of the sphere. In case of diameter form of the sphere, we have to find the equation of sphere whose two endpoints of a diameter are x1, y1, z1 and x2, y2, z2. Let us draw the figure. Now I will draw a sphere. This is a sphere. Let us draw a diameter. This is the diameter of the sphere whose two endpoints of a diameter are, the first endpoint is A, that is x1, y1 and z1, and another endpoint of a diameter is B, whose value is x2, y2 and z2. Let us take P into bracket x, y, z. Be any point on the sphere. Now we have to join AP and join PB. Then the angle APB is equal to 90 degree as the angle in a semicircle, since AB is the diameter of the sphere. So I will repeat it once again. Let A into bracket x1, y1, z1 and B into bracket x2, y2, z2 be the two endpoints of a diameter. So A and B be the two endpoints of a diameter. You have let P into bracket x, y, z be any point on the sphere, then join AP and BP. Then the distance AB is the diameter of the sphere, therefore angle APB is equal to 90 degree. That is, AP is perpendicular to BP. Now we have to write down the direction ratios of the line AP and the direction ratios of the line BP. The direction ratios of the line AP are x minus x1 comma y minus y1 comma z minus z1. That is nothing but the direction ratios are denoted by the first direction ratio is nothing but A1, y minus y1 is nothing but B1 and z minus z1 is nothing but C1. As we know that we can find the direction ratios of the line AP by subtracting second point minus first point. If you see this line AP, the point A is x1, y1, z1 and the point P is x, y, z. Then the direction ratios of the line AP can be obtained by this x minus x1. Second one, y minus y1, and similarly z minus z1. Second point minus first point gives the direction ratios of the line AP. Similarly, we have to find the direction ratios of the line BP. The direction ratios of the line BP are, you can see the line BP where the point B is x2, y2, z2 and the point P is x, y, z. Then the direction ratios of the line BP are this x minus x2. I will write here x minus x2. Similarly, the second direction ratio is y minus y2, that is y minus y2, and the third direction ratio is z minus z2, that is z minus z2, and these direction ratios are denoted by this is A2, B2 and this is C2. Since AB is the diameter of the sphere, therefore AP is perpendicular to PB. Then by using the condition of perpendicularity, if A1, B1, C1 and A2, B2, C2 are the direction ratios of the two lines, then the condition of perpendicularity is given by A1, A2 plus B1, B2 plus C1, C2 is equal to 0. By using this condition, we have to find the equation of the diameter form of the sphere. Then we have to substitute the value for A1, A2, B1, B2 and C1, C2. We get, that is A1 value is x minus x1, B1 value, A2 value is x minus x2 plus B1 value is y minus y1 into B2 value is y minus y2 plus C1 value is z minus z1 and C2 value is z minus z2, and that is equal to 0. So, this is called the equation of sphere in diameter form whose end points of a diameter are x1, y1, z1 and x2, y2, z2. Find the equation of the sphere whose end points of a diameter are 3, 4, minus 2 and minus 2, minus 1 and 0. Also, we have to find the center and radius. Let us draw the figure. So, this is a sphere whose end points of a diameter are, these two are the end points of a diameter, where the first point is given 3, 4 and minus 2, and the second end point of a diameter is given minus 2, minus 1 and 0. Let us consider this is the first point, that is x1, y1 and this is z1, whereas the second end point of a diameter is x2, y2 and z2. Now we have to solve this example by using the diameter form of the sphere. So I will write here diameter form of the sphere by using the diameter form of the sphere. That is x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 is equal to 0. Now you have to substitute the value for x1, y1 and z1. x1 value is 3. From figure we will come to know that the value of x1 is equal to 3, x2 is equal to minus 2. y1 value is 4 and y2 value is minus 1. z1 value is minus 2 and z2 value is 0. You can see the value of x1, y1, z1 and here x2, y2 and z2. So we can write it as x minus 3 into x, this minus into this minus becomes plus, so you will get plus 2 plus y minus y1, y1 value is 4, so that is y minus 4 into y, this minus into this minus is equal to plus, so you will get plus 1 plus z minus into this minus is equal to plus 2, so this is plus 2 into z minus 0 is equal to 0. Now simplify this, x minus 3 into x plus 2. So this x into x is x square. This x into plus 2 is equal to 2x. Now minus 3 into x is equal to minus 3x. And minus 3 into plus 2 is equal to minus 6 plus. Now you have to simplify this y minus 4 into y plus 1. So here also y into y is equal to y square and this y into plus 1 is equal to plus y. Minus 4 into y is equal to minus 4y and minus 4 into 1 is equal to minus 4 plus. You have to simplify z plus 2 into z minus 0. This z minus 0 is nothing but z only. So z into this z is equal to z square and this z into this 2 is equal to 2z. Right hand side we have 0. Now first of all write down the term containing x square, y square and z square. So I will write here x square plus y square plus z square. Now write down the term containing x. The term containing x are 2x and minus 3x, and 2x and minus 3x is equal to minus x. The term containing y plus y and minus 4y is equal to minus 3y. and the term containing z is only plus 2z. Now the constant terms are, this is minus 6 and minus 4. Minus 6 minus 4 is equal to minus 10. So that is minus 10 is equal to 0. So this is the equation of the sphere. Now we have to find the center of the sphere. So I will write directly the center of the sphere by dividing throughout by the coefficient of x, y and z by minus 2. The condition is the coefficient of x square, y square and z square is equal to 1. So here the coefficient of x square is 1, coefficient of y square is 1 and coefficient of z square is 1. So now we can write the center directly. So that is, here the coefficient of x is minus 1, and if you divide it by minus 2, you will get 1 divided by 2. Next, the coefficient of y is minus 3 and divide it by minus 2. So minus 3 by minus 2 is equal to plus 3 by 2. And coefficient of z is plus 2, divide it by minus 2, you will get minus 1. So this is the center of the sphere. Therefore, radius we can write it as radius is equal to square root of, now I will write directly. So here the value of u is 1 by 2. So 1 by 2 square is equal to 1 by 4 plus minus v value is 3 by 2 and its square is 9 divided by 4 plus the value of minus w is equal to minus 1 and its square is plus 1 minus this is the value of d. So d value is equal to minus 10 minus and this minus becomes plus 10. So if you simplify this, you will get square root of LCM is 4, by using cross product 1 plus 9, this 4 into 1, this 4 into 1 is equal to 4 and this 4 into 10 is equal to 40. So total you will get square root of 44 plus 10 is equal to 54 divided by 4. So this is the radius of the sphere. Thanks for watching. If you liked the video, then subscribe my channel and share. See you in the next video.